Hello, everyone. This is Baron Schwartz with VividCortex, having a small amount of trouble with Google Hangouts. I had to switch browsers. Kept crashing on me. So I'm just going to wait for just a moment. If you would, just tweet and mention VividCortex if you can hear me. And I'm just going to wait a moment, make sure that this is working okay. Okay, great. Sorry about that, and thanks for sticking with me. I got confirmation on Twitter and a couple other places that the audio and video are working now, so let's go ahead. Unfortunately, there's quite a delay between what I do and what shows up online, so it'll be a little awkward. But got all that solved now. Okay, so if you would, tweet questions to me. I'm not watching the YouTube comments, and they don't tend to be a very good medium for interacting live like this. But if you have comments or questions, just tweet them to me. I'm watching our Twitter stream. You can mention my username, XAPRB, or you can mention VividCortex's username. Either way is fine. And I will try and answer your questions as I go. And if I miss any, I'll answer them on our blog later. We'll do a follow-up blog post and answer all of the questions that you might have. So as I mentioned, my name is Baron Schwartz, and I'm the CEO and founder of VividCortex and author of High Performance MySQL. And we use Go a lot at VividCortex. Our APIs are built in Go, our agents are built in Go, all of our Kafka consumers, a whole bunch of, in fact, we pretty much standardized around Go as our tool chain of choice for everything from deployments to cron jobs, all kinds of different stuff. And so we use MySQL in our backend as well, use it quite heavily, in fact. And so MySQL and Go together has become part of our reality and something we've learned quite a bit about and tried to learn and share equally with other MySQL users and Go users. This is my contact information. Feel free to contact me anytime, connect to me on LinkedIn. Always enjoy hearing from people and staying in touch with people and having good conversations online and offline. Vivid Cortex is database performance management for MySQL. You can think of us as being similar to New Relic, but very much focused on the database layer, if that makes more sense. High resolution, 1-second resolution measurements of everything about your system, from the operating system to the processes running to the queries running, particularly the queries. We focus in on query activity and queries as the unit of work that your database servers are doing for you. And at the moment, we have MySQL in GA supported mode, and we have Postgres, Redis, and Kafka in private beta. And we're bringing more database and data layer products to our user interface over the next couple of months. Get in touch with us if you're interested in any of that. At a high level, we provide a really fine, detailed, very, very deep level into the work that your systems are doing for you, and a unified view of that over all of the systems in your data tier. So what you're looking at, this little screenshot, for example, here is from some of our systems, our production environment, in fact. And you're looking at the classes of queries, the types of queries that tend to run in our systems. And we have a bunch of high intelligence, data visualization heavy types of views into system activity like that. So as I mentioned, we use Go heavily, and I chose Go actually at the founding of the company. I was trying to decide what technologies would be suitable for writing our agents. For a little bit of history, I was one of the, I'd say, the third musketeer at Percona for 4.5, almost 5 years. And I wrote what became Percona Toolkit, which is open source command line tools for administering and analyzing MySQL, doing all sorts of things. And that became the inspiration for leaving and founding Vivid Cortex. And I learned a lot. Those tools are written in Perl. I learned a lot about how to write programs that can be run in an emergency situation when you're, say, a consultant who's called in to fix a system that's kind of on fire. And I knew that I didn't want to use Perl for a couple of reasons. Low performance, difficult to get installed, interpreted, all of those kinds of things. Dependencies. A lot of these things make software difficult to install, and I knew that we needed to have agents that were incredibly easy to install for Vivid Cortex. And I might be wrong, but I think we're among the first companies to really centralize around Go for an agent-driven architecture. The reasons are fairly, when people build and distribute agents, they deal with a lot of the same kinds of things that I was trying to get away from, and the reasons that I chose Go. So a bunch of other companies are doing that as well now. There are lots of companies who have Go-based agent architectures. Early on, I asked some people for some advice about which programming languages to choose, and I said I'm considering Go because of some of the things that I've listed on this screen, concurrency, performance, static linking in particular. Static linking is a really big deal, so that you can build self-compiled, self-contained binaries with no external dependencies and distribute those. And the advice, I got a couple of people's advice. Some people said, you'll never go wrong with Java, but I knew I could go wrong with Java because Java requires a runtime to be installed, and it's anything but self-contained. And other people said, C, C++, you got to go close to the metal. But the modern development environments with C and C++ include things like the Boost libraries, and I'd had some experience with that. Getting them to statically link and produce a self-contained binary is anything but easy as well. So there were objections to everything except Go, and the objections to Go were, well, it's really new. It's really bleeding edge. Maybe you won't be able to find any programmers. And remember, this was a couple of years ago. Now Go seems like a lot safer choice, but at the time, Go was very much a niche product, a niche programming language. And I tried it for a couple of months and really fell in love with it. So what I love about Go is that it's a minimalistic language. A couple of months ago, somebody published a blog post that said, Go seems minimalist because it only solves real problems. And I think that pretty much sums up the Go philosophy, is only solve real problems. Whereas a lot of languages will solve things with endless language features, making the language very confusing and rich and hard to learn. One of the languages I looked at is Scala, for example. Beautiful language, but boy, it's just the surface area and the learning curve there is huge. Go takes the opposite approach. Go is in the C family of languages, but it's actually only half as complex as C itself. And that's standard old C, not C++. Go is a very simple and direct language in comparison with C. But despite it being simpler and having only half the keywords of C, it actually has a lot more power. Among those include interfaces, which is duck typing taken to an extreme. If it says that it can quack like a duck, then the compiler will figure that out, and you can write your code around things that have quack interfaces, or in Go it would be called the quacker interface, and the compiler figures that out, and then it's safe to use. So there's it's compile time duck typing, and that turns out to be immensely powerful. We just put out a blog post today about how we take advantage of that for transparently encrypting the data that we store in our databases. All of our sensitive data is transparently encrypted, and it's stored encrypted at rest as well as being encrypted in flight, and Go makes that incredibly easy for us. The complexity for the programmer is no greater than not encrypting. And interfaces are really one of the things that makes that possible. The concurrency primitives are another big deal. Channels and the select statement and so forth. If you're not familiar with those, Go has a beautiful concurrency model built in that feels very much like Unix pipes and filters. And I knew I needed that in particular with the agents doing some performance and sensitive things and doing a lot of work concurrently. That's a nightmare to manage in most languages. The syntax is direct, very, very direct. Even simple things like semicolons are eliminated from the language when they're not needed. Braces and parentheses and so forth, all of those things are eliminated from the language. So the syntax is very direct, and there's never any magic. If you read the code, you're looking at what's executing. It doesn't have hidden things behind it. It is high performance. You can get higher performance with C, but Go, with a little bit of work, can be extremely high performance as well. And I mentioned static linking, so we can distribute a single binary. And then the toolchain. The toolchain is amazing, including, for example, a formatting tool, which is the standard for everybody in the community to use. And just, I can never imagine going back to a programming language where indentation styles are an item of debate. It's just not something you think about when you're writing Go, and it makes for a lot more productivity. So those are some of the reasons that we chose Go at Vivid Cortex. What's not as great about Go, or the things that I found a little bit missing, it's difficult to Google search for Go, so you need to use Golang instead, and almost everybody's kind of caught on to that, and they use Golang as a search term in their web materials, so you can pretty much find anything worth finding with Golang search term now. Package versioning is not built in, and there are good reasons for that. And the Go core team has said that's not a problem they're going to solve. That's a community problem to solve. There's a couple of different ways to do that. You can vendor in your dependencies to make sure that you've got reproducible builds and that you're building against exactly the versions of exactly the libraries that you want. So you can include them in your source repository, and there's a tool for doing that called GoDeps. And then another way is to use manifests, which is a file that indicates which imported code you're using, where you got it from, and what version you've imported it. And we've written what's, in my opinion, the leading tool for that approach, which we use together with a couple of other things to produce 100% reproducible builds from the manifest file. So we have a tool chain there, and it's on GitHub for you. Final complaint that a lot of people have about Go is that it doesn't have generics. So if you have a min and a max function, for example, you'll have to write one for floats, and you'll have to write one for ints, and you'll have to write one for anything else that you want. There isn't a generic min or max or similar. However, interfaces turn out to be a really good answer to a lot of the cases where you would want to use a generic instead. And in the remaining cases where you have like a sort function or a min or max, I honestly have not found that to be a really significant pain point. It's just, it's 5 lines of duplicated code in just a couple of cases in our code base, which is pretty large at this point. So the objections to Go are quite minor, very, very minor. So that's a brief introduction to Go. What I wanted to spend most of my time on during this talk is how to write code against databases, and particularly MySQL with Go. Design patterns, if you will. We don't really talk much about design patterns in Go, but this is kind of along those lines. So there's a few things to know about how Go interacts with databases. And these are some of the things that I'm going to go through in this talk. So let's go right on through it. Go has a built-in standard library, which is essentially the core packages that come distributed with the Go compiler and runtime and toolchain and all of those kinds of things. And part of that package, part of that standard library is a package called Database SQL. And this is intended to be the default interface to row-oriented SQL-like databases. You can use it for other things. For example, one of my friends wrote a driver for Neo4j, which is a graph database, and it uses the database SQL package interface. So it can be extended beyond SQL-like databases, but it certainly is kind of designed first and foremost for a relational type of data access. And it has a few different types of verbs and nouns that we kind of need to know about. The surface area of it, though, is not very large. So we can open a database, we can prepare a statement, execute, we can run queries and run queries that return a single row. And then after we've executed a query and fetched rows, we can scan those columns into variables in our code, and we can close the result. The nouns are the DB, which represents a connection pool to a database. It's not a connection, but a connection pool. Statements, values, and rows, and results, and so forth. And then we can also do transaction-oriented things, which bind you to a particular connection from the pool instead of potentially running statements on different connections, which is the default if you're not working within a transaction. The documentation is all at golang.org, and that's the authoritative canonical way to learn about database SQL. However, because it's generated from the source, it doesn't have a whole lot of user stories in it, hence the need for talks like this. And related is that we've, together with some other Go enthusiasts, we've put together a website that's intended to be a good set of tutorials and stories about how to use Go with databases. And that's at godatabaseSQL.org. And that's an open source website, so you can contribute as well. So let's look at some of these things. This is a minimalistic program in Go to access a database, a MySQL database in this case. We begin the file. This is the whole file, the whole program. It's kind of the hello world for accessing a database. We begin the file with package main, which is always at the top of your file, package name. And then we import some external code. The first import statement starts with an underscore, which means that that imported code is just being imported for its side effects. And behind the scenes, it registers itself with the database SQL package, but it doesn't become available to our scope here. That's why we use the anonymous underscore identifier in front of it, so that it isn't actually bound to our scope. Now you can actually import it and reference things in it if you get rid of that underscore, but this is the default way that you'll most of the time access it. You don't access the driver directly. Instead, you work through the database SQL interface, and that interface interacts with the driver behind the scenes for you. The imported code there, that's actually the URL where you can go find that code, and the Go toolchain will go to that URL and download it if it needs to in order to build this. And so github.com, Go SQL driver MySQL is the database SQL driver that I recommend. Of all the ones that are out there, it's the one that's most idiomatic and I think the highest quality. And at this point, it's gotten contributors from Google's Go team, their core team to work on it. And so I think it's by far the most active and the best maintained of the drivers out there. It may not be the one that is most popular according to search engine results, but I definitely recommend using it. So we've imported our driver, and now we need to import database SQL and the log package. Log is for printing output to the terminal or to a log file, as you choose. And then our main function, this is where all the action happens. We open, we use SQL.open, and SQL is the namespace that gets imported by database/SQL. By default, it's the last part of the import name. So that's how we can refer to it. So SQL.open, and then we give it the name of the driver, MySQL. And then there's a string which the driver is supposed to interpret. It's opaque to database SQL, but the driver is supposed to understand how to parse out the instructions to connect to the database. So in response to that, we should get back a DB object and possibly an error. In Go, you always handle errors explicitly. There are no exceptions that interrupt your flow. So you always capture an error and then check whether it's nil. In this case, if the error is nil, all we're going to do is print it. And then we close the database with db.close, but we put the defer keyword in front of it. That's also idiomatic Go for when you're opening something and you're going to want to close it or clean it up much later. You do that right where you open it, and then you defer it, and when the function returns, it'll get closed. So you'll see that pattern several times. Next thing I'm going to show you how to do is a one-shot query. And all of the code samples from here on in assume that we've got kind of that boilerplate framework of package main and importing database SQL and all of those kinds of things around it. So you can consider this a little snippet from the middle of that file. So we're going to do a one-shot query where we grab one row out of the database. And to do that, we're going to need a string variable to hold the result. So that's the first thing I do, is declare the variable. And then I use the db.query row and give it a string that represents the SQL. So select hello from hello.world where ID equals 1. And then that returns a row, which I then scan into the address of the string. So once database SQL has a row, you give it destination addresses for where to put the contents of the columns. So you'll notice that you manage memory very, very explicitly here. You have to create the containers for the data right there in your code, and then you copy values into them. Go is fanatical about memory management and about making that very visible to the programmer, so that you are not creating and destroying a lot of memory in ways that are kind of obtuse to you or obscure to you. There are no abstractions around things like that in idiomatic Go. So we created a row, we created a string variable, and we've scanned this row into it, and then we check whether we got an error from that. The error actually comes from the .scan. There's a couple of different ways to query the database. One is to query and get a row set back, and then the other is query when you expect exactly one row. Well, what if you don't have one row? What if you have two rows? In that case, then you'll get a special error, and this is the only case where you'll get that error, the SQL.error no rows. So you have to compare it against that to see if you got that error. If you got no rows, then that may or may not be an error in your code, and you handle it appropriately. So what we're saying here is if we have an error from this whole operation of querying and scanning, and the error is something other than we didn't get a row, then we're going to print it. And then we'll print the string variable. That's the one shot, one and done, grab a single row from the database. The variation on that for getting multiple rows from the database is db.query. So here I'm going to select two columns also to illustrate that. And this code continues on to the next screen. So the entire code isn't shown here. So I'm creating two variables, an ID and a stir. one's an integer, one is a string. And then I'm creating a variable for my query text, the select ID, comma hello. And I'm also putting a placeholder in here. So before I had my my hello.world ID as a literal. And in this case, I'm putting a question mark placeholder. And this starts to introduce the notion of parameters to queries. In the fourth line of code, when I do db.query with my query string and then the value 1, behind the scenes, the database SQL and the driver are going to they're going to prepare a prepared statement and then execute it with the value 1 going into that prepared statement placeholder, the question mark. And this should be familiar with if you're used to parameterized statements at all. And then the result of running that db.query is one of the results is an error, so we check for that one. And then the other is a rows object. And it's kind of conventional to call it rows if you only have one of them. And then again, we're going to defer rows.close because we're going to iterate over the rows, the result set that rows represents. And when we're done, we need to close it. So again, whenever you're going to do something, do a bunch of work and then clean up, you go ahead and defer the cleanup right up front. And that keeps all that code together and makes sure that you don't forget it later. So this is the continuation. And now we just, in a loop, we call rows.next. And this is Go's variation of a for loop. It doesn't have a whole bunch of different forms. There's just one form here. You do for, and then something that evaluates to true. You can do something C++-ish also with semicolons in there, but this is the default, is just a for something that returns true or false. And so what we're doing is we're calling rows.next, which advances the cursor onto the first row of results, and then we scan it. So that fetches the results from the database, and now we scan it into our variables ID and stir, and again by location there, memory location with the ampersand up front. And we check for the error, and then we're going to do something to use the variable scan from the row, like print them out or do some computations or something like that. At the end of our for loop, we're going to check and see if there was an error during the loop. There's a couple of cases where that rows.next will return false. One is when we hit the end of the result set. And the other is where something happens like an error communicating with the database, fetching the rows from the database. And if that's the case, then we're going to have a deferred error stored inside of the rows object. So we need to check and make sure, did we exit the loop because we were done, or did we exit because of an error? And the rows.close here is really just redundant. If there was an error or if we run off the end, it's already been closed. That's guaranteed to happen in database SQL. So I should remove that line of code. I forgot to remove it from my presentation. And then we're going to print out that error. In this case, I'm using log.fatal, so we'll crash the program. We'll print out the error and then exit with a non-zero exit status. But this is the idiom. You on the previous slide, you query and you create your result set, you defer closing it, and then you iterate over it and do something, scanning every row in and doing something with it every time. And then when you're done, you check the error and see if you need to handle it. And by the way, for little goofy examples like this, you almost always just log.fatal or something like that, print out and exit. But in real code, you almost always handle the error and do something sensible. You don't just exit the program. Another variation on this is to prepare that statement explicitly and then get a prepared statement handle that you can reuse multiple times. This, let me bounce back here a little bit. This db.query internally prepares, executes, and then closes a prepared statement. So you'll actually see 3 database actions. If you're using something like Vivid Cortex, where you can see all of the network traffic in production, you will see those actions specifically and independently. In fact, I'm going to bounce back to that screenshot that I showed you earlier. I just want to show you something that I just remembered about that screenshot. Queries number 5 and number 6 here. these select shard hostname from customers.env, those queries look identical. Number 5 and number 6 look identical. And in fact, they are the same query. But if I showed you another column in this user interface, you would see that we actually have a prepare action and an execute action. And we're capturing those things from capturing and decoding and measuring network traffic going to the database server. And so we capture preparing, executing, and closing prepared statements independently from each other. So you can actually see, and this is something I'm going to file an issue on later. If you look at the count column here, the count is, it's even a little bit higher for the query number 6. So we're basically doing duplicate work here. We should probably just get rid of the prepared statement, and I'll show you how to do that in a little while. In fact, I'll show you how to do that right now. Let's go back to our sample. This call to db.queryRow has no prepared statement parameters in it, and it has no arguments to be passed to that prepared statement parameter, which we would pass after this SQL string if we had them. And when that is the case, it will send the query in textual form directly to the database, one round trip, instead of doing a prepare, execute, close cycle. So this is one of the ways that you can avoid those redundant round trips to the database. All right, I bounced around a little bit. Hopefully you've been able to follow. So now we're going to explicitly prepare a statement and capture that statement in a variable that we're going to reuse hopefully multiple times. So we db.prepare, and then we give it the same prepared statement SQL with the parameter question mark. Now, one thing about that question mark, that is driver-specific syntax. For MySQL, it's going to be a question mark. For Postgres, it's going to be $signs and so forth. Some databases have named parameters as well. So that's actually not part of the database SQL interface, but it's part of how the driver interacts with the particular database that you've chosen. So we prepare, again, we check whether the error is nil, and then we defer, because a prepared statement is an item that needs to be closed up, cleaned up after you're done using it with close. So again, we defer that right where we created. And now we use this prepared statement to execute and fetch. So we're going to do statement.query, and now, because we're querying a prepared statement that already has the SQL inside of it, we only pass the parameters that go into those placeholders. In this case, it's the value 1. And everything else looks exactly the same as before. You know, we get our rows back, we iterate over the rows, and we check for errors and so forth and so on. So that's how you can create and use prepared statements. Now, inserts are a little bit different. We've been using query and query row so far, and query and query row are intended for fetching results from the database. There's a different set of things that you're intended to use when you're not fetching results back from the database, and that is exec. In this case, I'm going to prepare an insert statement with a parameter placeholder, and then I'm going to defer closing the prepared statement variable that I've got as a result. And now I'm going to exec that prepared statement with an argument, and that gets that hello Dolly gets inserted into the question mark placeholder, and I'll get an error back from that as well. And I also get a result, RES, a result object, and I can introspect with that result object some properties of what this statement did. But notice that I'm using exec instead of query. And there's a reason for that, and I'll talk about that in a few minutes. So I can use that res variable to check what was the last insert ID and how many rows were affected. And support for those varies by the driver. Both of those also return an error because they may or may not fetch data over the network. They may go talk to the database again, for example. And so we need to check for errors on those. But that's how you can get the last inserted ID and the row count of the number of rows that were affected by that statement, if the database supports them. So let's move on to learning about the how to use this, because I've given you a brief little walkthrough tutorial here, but there's a number of other places that you can learn about things. And what I found in learning about this was that I did it wrong more times than I did it right in the beginning, and I just didn't realize that. It's not that it's a steep learning curve, it's that I didn't pay enough attention and I wasn't really familiar with Go. So there's a lot of things that I missed even when I was trying to pay attention. Well, one of the things is that the documents, as I mentioned, are source-based, and that means that they're not very verbose and they don't have a lot of user stories and case studies and examples in them. There are some examples and test cases and so forth in the documentation. But for the most part, the documentation is written to say everything one and only one time. So if you're reading the documentation, read it really carefully. A lot of things I missed the first time through, and then I went back and I was like, how did I miss that? And it's because the documentation never says anything redundantly. Go's documentation is sort of like Go. It's minimalistic and it's necessary and sufficient, and that's all. You know, you don't get a lot of novels in the documentation. So something like databases connection pooling will be mentioned only once. So that's my next slide, actually. Connection pooling. I mentioned this just briefly before. It took me a long time to notice that Go, a DB object in Go, is not a connection to the database. I think I was just sort of stuck in a mind frame of having used and even written drivers for other languages where you open a database and that represents a connection to the database. And that is not the case in Go. It maintains a pool and you can't see the pool and you don't have a whole lot of control over it. There's a couple of parameters that you can set. You can set the maximum size of the pool so it doesn't open up too many connections, and you can set the minimum that you can basically keep a certain number of connections in the pool when they're idle instead of closing them right away when they get returned to the pool. But I didn't realize this, and it's only mentioned once in the documentation. So if you open up the docs and search for pool, I think you'll only find that word once on the page. This pool is transparently managed for you, so you don't see and interact with connections directly. When you do something like db.query, behind the scenes, it goes and looks for a free connection in the pool. If it doesn't find one that's free, it'll open up a new connection. If the connections in the pool are, if there are too many connections in the pool and you're running up against the limit, which is unlimited by default, then you'll block and wait until another connection is returned to the pool and it can be used. So what this does, actually, it's a little bit, it's a little different from some of the really explicitness of Go in some ways, where absolutely everything you do is explicitly shown to you and there's nothing magic hiding behind the scenes. I have to say this one is a little bit magic because you don't really know, am I about to open a connection, or if I, when I'm done with this, is this connection going to go back into the pool, or is it going to get closed? Or, you don't really know what exactly is going on. The other thing is, you don't know if you do multiple queries in a row, you don't know that they're happening on the same connection. And to get that kind of a guarantee where you have some connection state that matters, like being in a transaction, or maybe you've set a variable or a particular option or changed your current working database or something like that, you need to be in a transaction. That's the only thing that binds a connection to the actions that you're taking. So you need to be aware of that pool. And if you're not aware of it, you'll open up a lot of connections to the database when you forget to rows.close, or when you keep a statement open or something like that for a long time without realizing that it's consuming resources. Big unsigned integers. For some reason, you can't insert a parameter. Remember how we were placing parameters into calls like db.exec, and I was using the parameter 1 or hello Dolly. If you use a big unsigned integer, a uint64, and the high bit is set, if it's over half of its maximum size and that high bit is set, Go's database SQL is going to reject it. And this is something that I personally don't agree with. The reasoning behind it is that some databases don't have big unsigned integers, but I think we ought to be, that's something that the driver and the programmer and the database should take care of. I don't think that Go Database SQL should insert itself into the chain there and say that you can't interact with databases with larger than a big unsigned integer. So what you have to do instead is convert that value to a string representation. And I know that's ugly. It's not a huge deal. You just use the format package in Go, fmt.sprintf, and you turn it into a string representation of the big unsigned integer. But what'll happen, and why I'm warning you about this, is if you start out with some small values and they grow over time, and eventually that high bit gets flipped, everything's going to throw errors back at you. And that's something I don't want you to encounter later. I want you to know about that upfront. Another thing is, I mentioned you can create a lot of connections to your database server. And so if you are not releasing connections back to the pool when you're done with operations on them, you know, those connections are not going to be available for other things. You may be done with them, but you haven't released them back to the pool. And so the next time something else in your program does some operation on the database, it's going to open up a new connection. And so you can run your database out of connections real quickly if you do this. One of the things that you should do when you're done with a database result set, the rows variable, you should close it as soon as you're done with that for loop. Or if you exit out of the for loop early or something like that, you should close it as soon as you can. Don't keep it around any longer than you need to. And in some cases, I've rewritten code to pull some work out of the for loop. So I'll iterate over the rows really fast and get that done and return that connection back to the pool. And then I'll do the work on the rows, the data that I pulled back from those rows and stored into variables. And there's a couple of reasons you might want to do this. Among other things, you really don't want to keep long-running operations open to the database server. You want to just get done and close the result set and let the database server's query finish and free up the resources that it has. Another thing is, if you're idle in the middle of that for loop, some database servers, depending on how you'll have them configured, might actually time out and close your connection before you're done fetching the rows. So the moral of the story, and the way I've always thought about interacting with databases, is get her done, you know, start your query, start your transaction, whatever, do your work really quickly, and then close it so that you're not potentially blocking things or holding up resources or exposing yourself to some kind of like a timeout error or something like that. So that's just sort of general code hygiene and something that you need to be aware of. Even though that database connection pool is hidden from you behind the scenes, you need to kind of have it in the forefront of your mind when you're operating on databases with Go. Another thing is that you can actually use the database SQL package wrong and run into that exact problem. So if you are doing a delete or an insert or something like that, and you use a db.query to do that inside of a for loop, for example, db.query expects results to come back. Query is intended for an operation that will return rows back to you from the server back to the client. And if you don't consume those, they become an open row object that is bound to a specific connection and keeps the connection from going back into the connection pool. And so I've done this myself, the code that's on this screen, a couple of times, where I didn't need that row object that came back from the query, and so I just assigned it to the underscore, which is basically a throwaway variable. But the variable's actually there, and it doesn't get closed until the garbage collector comes along and reaps it, which may be minutes. And in the meantime, you're keeping all of those connections open in the pool. And what you'll do is open up a whole bunch of connections to the database server. So what you want to do instead is you want to use db.exec, which is not designed for rows to come back. It's designed for a result object to come back that you can query for things like the last insert ID and so forth. But that does not consume any resources and doesn't have to be closed. So this will not cause problems with the database connections ballooning. Another thing that I didn't realize is that a lot of the database SQL operations will retry for you. And I initially wrote some retry logic of my own until I figured that out that database SQL was doing this behind the scenes for me. So all of these operations like db.query, let's say that it picks a dead connection out of the pool, a connection that's been killed from the server because it's timed out from the server side. It picks it out of the pool. It doesn't know that it's dead, and it runs query against it, which promptly causes an error. Well, you won't see that because it will retry 10 times. And that 10 is hard-coded, and you can't change it. There's a couple of operations where it won't retry for you, but generally things like prepare, exec, those kinds of things, prepare, exec, query, those will retry for you. And in fact, if you have a prepared statement, that prepared statement is not bound to a single connection either. So if you prepare a statement and then exec it, and then sometime later you want to exec it again, but the connection that it was originally exec on has been pulled out of the pool and is in use somewhere else, it'll open another connection or pull one out, get one out of the pool, and re-prepare that statement and execute it again. So there's lots of retrying for you that happens behind the scenes. And if you don't want that to happen, this may sound a little bit funny, but you need to read the source code of Go Database SQL and understand what it's really doing for you. There won't be retries in particular cases, and there's only retries for particular kinds of errors. But for example, one of the funny ways that this can show up is if you have a long-running query and you kill it from the server. So in MySQL, you can issue a command, kill, and then you give it the connection ID of some connection. You can kill the connection, and your Go program is going to retry it. And the first time that I saw that, it was the whack-a-mole it was the whack-a-mole bad query that I didn't want to be running, and I had to kill it 10 times before it really died. So be aware of that. Nulls are a little bit funny. Nulls always make things really, really annoying. I try and avoid them whenever I possibly can, and I've done that for years. And I kind of appreciated that when I started to work with database SQL and Go. Nulls and nils and undefined are always a hassle and a source of bugs in any programming languages. So the way that works in database SQL is you can't scan a null into a variable. Like you can't scan a null into a string. If you try, you'll get an error during scan. So what you have to do if your data is nullable, you have to give it a nullable type to scan into. And this is just a type that implements a given interface. You can implement your own. It's only a few lines of code. And it's a structure that has a property to hold the value, and it has a function or a property called s.valid. And so the idiomatic way to do this, you can use the SQL.null string, for example. I don't know why I didn't qualify that with the package name, but that should be var s SQL.null string. And then if there was a null that came back from the database and got scanned into that variable, then valid will be false. So you can use you can check s.valid and then use s.string or s.int or s.bool or whatever the type is that you're looking at. But you can tell whether that value has been set or whether it was null. Now, if you don't care, in a lot of ways, Go has this concept of a zero value. So if you create a string, for example, it's not a null string. It's an empty string by default. And if you create an integer variable, it's not a null integer, it's a zero. There's this concept of a zero variable for everything in Go. And sometimes That's all I want. You know, I want to treat a null as a 0 or a null as an empty string. So in that case, you can get the same effect by just ignoring that if statement with s.valid. You can just use s.string. If there wasn't a value there, it's an empty string or a 0 integer or whatever the underlying type is. So I hope that makes sense. It took me a while to see that I could just use a null string and then just use the value and ignore whether it had been set or not. And you only want to do that in specific cases. I wanted to do that in specific cases where I didn't care. If it was null, I wanted to treat it as an empty value. Null does make the code ugly because you have this boilerplate if checks all over the place. And nullability is not future-proof. You might not realize that your code could occasionally have a null in it, and one day when it does have a null, then it's going to blow up. And there's not null uint64, so if you're working with those, you're going to have to deal with that yourself as well. One trick here, database SQL actually uses, when you scan into a variable, it looks at the destination type of the variable. And if it's a string, it'll convert it into a string. If it's an integer and the result that comes back can be converted into an integer, it will do that for you. So for example, in MySQL world, if you're selecting some, if you have a table whose data types are defined as strings, but there's only numbers in them, like the literal ASCII representation of those numbers, like 1, 2, 3, the characters 1, 2, 3, you can scan those right into an int, and they will get converted into a 1 and 2 and 3. So you don't have to scan them into a string and then use the strconv library to convert them into integers and do all the error checking and all of that kind of stuff. So that's kind of a handiness for you. You can get database SQL to do those conversions for you. That removes a lot of boilerplate code for you. ORMs. After a little while, you start to wonder, well, can't something write some queries for me? And yeah, there's some ORM-ish kinds of things out there, but Go is not really a language that can have ORMs, just for various reasons, mostly to do with the language. There's some stuff that sort of gets you halfway there, but this object relational mapping concept just doesn't work very well in Go. The MongoDB driver, by the way, maps objects to objects, and that works really well, but you can't really do the same thing with database SQL. The interfaces that Go has in the database SQL package are incredibly powerful. And that blog post that on Vivid Cortex's blog that we just published today about transparent encryption, the one that I mentioned earlier, that one uses the power of interfaces to do that encryption and decryption for us behind the scenes. So use them. The fourth link on this page with the resources here, Jason Moran's a blog. He's got a lot of really good articles about using the built-in power of Go and interfaces. And that's how we learned how to do that transparent encryption and decryption as well. We learned it from Jason. So the resources here, again, godatabaseSQL.org is your tutorial. It covers a lot of the stuff that I've talked about and some more. There's the driver that I prefer to use on github.com. And there's always our Twitter. Please follow us. We tweet links to blog posts, including our own. We blog a lot about Go. And some of the core Go community members will share some of the tidbits that you shouldn't be missing there as well as lots of news about MySQL. So I've been watching the Twitter stream. I've seen some people chattering about the talk, but I haven't seen any specific questions yet. So if you have anything, go ahead and ask there. Otherwise, I'll just wait a moment. And while I'm doing that, I'm actually going to show you this blog post that I was mentioning. And I'm going to have to unfull screen myself to do that. All right, so this is our encrypting data with Go, encrypting data in MySQL with Go blog post may be of interest to you. All right, I'm going to leave it at that. My contact information again, you can @ me on Twitter, or you can link me on LinkedIn, or you can just email me on the good old email. And I'd love to hear from you. Hope you've enjoyed this. Hope it's been helpful and educational, and love to hear from you. Thanks, everybody. Bye for now. Talk to you next time.